Hey guys, so I pulled out another old code that I'm going to walk through with you about some things that are wrong. And I thought you just might find this funny. So if you remember the last time I did something, I made the motors run if it was light outside. So something interesting to know is when you switch this thing on and if everything's hooked up and cooperating and the battery's in there, like here, it will it will automatically just start running whatever code you had. So I turned this on and my motor just kept running and it was highly annoying. So I thought you'd find that funny. So I just cover that little guy up and you notice the flashlight turned on, but that's okay because it's a lot less annoying than the motor. All right, so I just thought, hey, that might be something worth telling you guys is when you turn it on, it just goes through the last program you sent to it. If you look at my computer screen, that's not the code I have anymore, but it's the last code that I sent to my robot that worked. So the brain of this, the cortex, is going to use that. All right, let's take a look at this code that I put in there. Let's find some mistakes. And let's talk about what it's going to do. Gracie, you asked an absolutely wonderful question. She asked if I had to do while one equal one, or if you could put any statement in there that's true. You could absolutely put any statement in there that's true. So I'm going to show you one that I played around with yesterday. So this exclamation point means not, and then equal, how about two? So that's a true story, right? Like one does not equal two. So like as long as what's in here is a true statement, then you're good. It's going to make it run forever. Notice this program I made has a lot of comments in it. All right, so let's talk about what's going on. So between here and here, this stuff is going to repeat forever. So let's see what, and the point of this particular one is to show you that you can put while and if statements inside of other while and if statements. I always suggest to kids that they really space them out. So in fact, like I think I could essentially space this out even more, like this. And the number of enters doesn't matter, but then like you section it off. Well, so let's take a look at what's going to repeat forever. So it says sensor value. You can see I have some yellow and red X's. So let's just figure out what's going on. Sensor value of the light sensor, I think we called ours capital S, is, and what's kind of neat is that you can start typing and it's going to pull up whatever you have. So I think we have, do we call it light sensor? I think we called it light sensor like that. Usually it pops up when it types, but let's see. So if the light sensor is greater than 700, now I'll tell you what I mean here. So here, later than 700 means, I think that means that it's dark. So this is while it's dark. Okay, so while it's dark, let's see what I want to do. If we turn the limit, I bet that's a capital S. If we turn the limit switch on, the limit switch is this tiny little clickable thing. Listen. If somebody pushes the limit switch, notice the difference. I used an if here because I just wanted to know if somebody does push the limit switch. This does not say while, because if it's a while, I would have to be holding the limit switch down. So if the limit switch equal one, that means it's being pressed. 0 means not being pressed. 1 means being pressed. And just take a look at the format, please, of all these parentheses and how you kind of work the limit switch as a sensor value. You put your name in parentheses and you put your if condition in parentheses too. So if someone presses the limit switch while it's dark, I want the flashlight to turn on at full value 127. This is a command, so it gets a semicolon. This is not a command. It does not get a semicolon. Now else. So that means that this limit switch is false. In other words, I could have put if limit switch equal 0. But else, turn the flashlight off. Even if it's dark, keep the flashlight off. Okay, now I think everything looks good here. So this means right here, just to type in some pseudocode, which means to type in human language here. This means if someone presses limit switch. And then we know this one means turn on flashlight. You don't have pseudocode everywhere. And this else, remember this else meant that if someone does not press limit switch. So this limit switch, the flashlight's only going to turn on if the limit switch is pressed. And then it's automatically, once you let go, it's going to turn into this else statement and it's going to turn it off. So I guess I could use a while there, but I'm not going to. Maybe I can even show you how that works. So let's talk about what this particular while statement does, because this is inside my other infinite loop. So while the sensor value of the light sensor is less than 700, I should probably put like an equal to somewhere because I don't think I had an equal to up here. Yeah. So as long as it's less, in other words, when it's bright, this means while it's bright, turn the flashlight off no matter what. Okay, so let's go ahead and run this and see if it's angry about anything. The goal of this particular item is for me to show you that you can put while and if statements inside of while and if statements. Okay, so it looks like I have too many braces. Let's look at 67. Let's see. Stops program. Oh, we already have one of those, don't we? Because this one ends the task. So this one ended my infinite while. I'll put infinite while. I had that 1 not equal to 2 loop. So that one equals, that ends the while loop, and then this just ends the program. So it looks like I had one too many on there. Okay, so I'm gonna take my phone off now because I think we're gonna be good. I think it's gonna run really well. Oh geez, hold on. It's still trying to load it. Everything's connected up, computer, did a hard reboot. Okay, everything's happy. All right, so I have this new program now. Notice when I take away my phone. So let's take a look. I had nothing to do. There was nothing about the push, the button. What is that called? push button. I forget what that's called. I'm like bump switch. Thank you. Nothing that has to do with the bump switch on this one. Everything that had to do with the flashlight and the limit switch. So right now in my house, it's light. So I'm going to hit start. I forgot I have to hit start. What I want you to see is it's light in my house. So because it's a light, we're going to stick right here at this turn flashlight off. Now what I'm going to do is I'm going to make it dark. I'm going to make the Cortex think it's dark by covering the light sensor with my phone. So covering, it's definitely dark. If I go down here to look at the sensors, let me get rid of this. You can see that, yeah, it definitely thinks it's dark in here because it's above 700. So the flashlight's going to turn on, but the flashlight is only going to turn on if I press the limit switch. So let's see if my program's good. Ready? I'm going to push the limit switch. There's your flashlight. So you can see that right now it's really floating in this top while loop because it's dark. And inside that while loop, it is continually checking for this limit switch. So it's going to check for the limit switch. Limit switch is not on. Turn the flashlight off. Limit switch, turn it on. Now, something that's interesting about code is how easy it looks when somebody else types it. So here soon, after I show you maybe a couple more things, I'm going to have you guys type me some code, and we'll practice and see how you guys are doing. Biggest thing I see is people having a lot of trouble with their braces, and I want to show you this. You can always, if you're struggling with typing in Robot C, you can always start by typing it in a Word document and copy and pasting it. Or that this might be the best way to send it to me, is make it in a Word document, send it to me. We'll run it and see how it goes. Now I'm going to go ahead and type one more code in there, maybe put some new stuff in that you haven't seen, and maybe we'll get you started in making your own. Okay, guys, I changed it up just a little bit, and I know I got definitely have some mistakes in here, and I did that on purpose. But let's go ahead and let's acknowledge that I'm going to run it forever because I wrote while 1 does not equal 2. Remember, you can do like while 1 equal 1. You could even do while 1 is greater than 0. That should still work. Any true statement inside of there. So what we're going to do is let's see if I did it right. So I have another while statement. Let's see what I want to happen. While the sensor value of my ultrasonic, that's the sonar over here. Oh, here, let me move the camera. There's my sonar. If it's greater than 12, in other words, it's going to try to sense an item. And I'm saying as long as that item is, you can't see me. As long as that item is 12, like 12 or higher, I want something to happen. So as long as like nothing's obstructing it, in other words. So if nothing's obstructing it, if it's like 12 inches or higher, I want, so let's write that, nothing within 12 inches. That's kind of nice to have that. So while nothing's within 12 inches, it's going to do this. It's going to check this potentiometer, this little twisty guy right here. And remember the value of the potentiometer changes based on like how much you spin it. So here, I just spun it all the way to one side. I don't know if I spun it to 0 or if I spun it to 4,095. I really don't know. I'm guessing that's 4,095. I'm guessing that's 0. But if it's smaller than 4,000, so I'm going to write // po, I'm just going to do that, smaller than 4,000. Let's see what's going to happen. The right motor is going to start. So that's cool. And if this isn't true, so this else means that the potentiometer is greater than or equal to 4,000. We're going to start the left motor. Now, I know I purposely did something wrong in here. We'll talk about that. I think sometimes that's the greatest way to find your mistakes is to try to figure out like what's wrong with your code. So let's run it and you guys are going to see a mistake I made. Probably, then there's going to be more than one. All right, so the first thing I did is this start motor needs to be a capital S, which isn't that big of a deal. They said, okay, no problem. They'll deal with that. And so is this one. This one should probably be, I bet this one should be a capital S. And let's see, I'm just going to back off. There you go. It should be it. That's what it should look like. Should be that. I like to use theirs as a hint. Okay, so that would make them all happier. However, it's still going to run. There's no red, which is kind of nice. Let's hit start. Oh, so let's see where we're at right now. Right now, my potentiometer is at 0. So because my potentiometer is at 0, I'm going to stop this because it's really loud. Because my potentiometer, look where my arrow is at 0, it's going to go right here and it's going to start my right motor. Does everybody see that? Kind of cool, right? So the potentiometer, when I turned my program on, was smaller than 4,000. So it turned my right motor on. It never did this. Now I'm going to show you something, and this might boggle your mind, and it'll be great if you can come up with what's wrong. So now what I'm going to do, guys, I'm going to turn my potentiometer. I'm going to turn it up past 4,000. Look at the value of my potentiometer. It's going up. Almost at 2,000. 3,000, ready? 4,000, something's going to happen. Both of the motors turned on. Now, I'm going to pause it. Did you guys kind of think that my right motor should have turned off? Because in the program, I kind of like wanted that to happen. But here's the thing about a computer program. It's literally like teaching children. If you don't say it, it's not going to happen. So what I need to do is if I only want my right motor to run here, you know what I need to do? I need to say stop motor, left motor. And down here, I need to say stop motor, right motor. So if you don't tell it to stop, if it ever starts, it's never going to stop. Let's run my program again and see if it's better now. Oh, and I'm going to play around with that ultrasonic thing too. I think you guys are going to like this. Oh, actually, I'll be interested. Let's see what happens when something comes in within 12 inches because it's going to jump out of my while loop. I'm very interested to see what happens. Let's see. Okay, I'm going to hit start. You should notice my potentiometer is at 4095. So if I did everything right, only my left motor should turn on. That is correct. Now I'm going to turn my potentiometer, and it's only going to turn on my right one. Now I'm going to turn my potentiometer again. It should only turn on my left one. Now, I want to put my hand above the ultrasonic. In other words, I'm going to make it jump out of this while loop here. Now, I'm going to stop it. My ultrasonic, look at where you are. Look at my hand right here. Look at my arrow right here. See, my ultrasonic says, hey, there's something within 1 inch. So again, you might say, how come your motors didn't stop? My motors didn't stop because I never told them to stop. Like if my motor's turned on inside of here, my motors are never going to stop. So inside right here, if I want everything to be off, I need to tell it. So in other words, hey, if you ever jump outside of this loop, I need you to stop my motors. So let's go ahead and say that. So I'm going to back up. I'm going to say stop motor, left motor. I thought there was a way, and maybe you guys want to research this. I thought there's a way to turn off all motors at the same time. I'm not in the mood to research it right now, but all right, guys, let's see what happens now. Now, these two things exist within the infinite while loop. So we should be able to go back and forth and back and forth. Let's see how we did. I know, guys, this is not like as much fun and stuff without you being able to try it yourself, but I want to run some code with you and spend some time with your codes. Okay? Because it's not cool unless you get to do it too. I understand that. All right, let's see how it works. Okay, I'm going to hit start. Remember, nothing is obstructing my sonar. Because nothing is obstructing my sonar, it's checking my potentiometer. My potentiometer is at 4,095, so it's going to turn on my left motor and keep my right motor off. Now, I am going to turn my potentiometer to smaller than 4,000. My right motor turned on. Now, if I did my job right, when I obstruct this ultrasonic rangefinder here, it should shut off my motors. And it did. So what's happening right now is it is running through this loop and it's saying, hey, my ultrasonic is not right here. It's going to go away when I let go. It's going to check my ultrasonic and it's going to go say, hey, my ultrasonic is not greater than 12. So I'm not going to do anything inside of that loop. Now, guys, I'm going to watch my hand. Ready? When I get to 12 inches, and this is like crazy accurate. When I get to 12 inches, it's going to go back to that while loop. Not at 12 inches yet. Ready? There it is. Oh, I must be right at that 12-inch mark. So if I got a ruler, oh, look at that. It's like sensing my hand because I'm moving. Now, if I'm up here, I'm definitely 12 inches above. Ready? I don't know why I find this so much fun, but I do. Ready? Here we go. Ready? Best part. Hey, stop. Okay. Anyway, that's fun for me. It would be more fun if you were here. All right. I'm going to pause the video. There might be one or two other things I haven't talked to you about. I just want to make sure I hit everything. Okay. Something I did not teach you yet is how to set like an integer. So I'm going to show you something, and it's going to be called I'm going to make a variable, and that variable is going to stand for how many times I push the bump switch. Okay, or the limit switch, or anything you want. You would have a count all kinds of stuff. But I'm just going to make it easy. I'm going to count how many times I hit the bump switch. Okay, so I'm going to do int, which stands for integer. I'm going to put number of presses, which stands for how many times I press it. Hold on, I'm on a YouTube video that walks me through this because I had forgotten. And okay, you're going to set it. All right, now I got to space it out. Okay, ready? So I'm going to call it int number of presses with no parentheses. And I'm going to set it before my task main. I'm going to set it equal to 0. So anytime at the beginning, anytime it sees number of presses, it's going to think that that's representing like the number of 0. Okay. Now what I'm going to do with this is every time I press my bump switch, I'm going to make my number of presses go up by 1. And I'll show you how to do that, but I got to pause it for a second. Okay. So I'm going to delete a lot of stuff underneath of this, but remember, I called something that's called number of presses. I literally could just call it X if I wanted to call it X. I mean, that would be fine. You can label it whatever you want. Number of presses. You don't have to. You can call it X if you want to equal 0. So here's my infinite loop until I press my button switch. Now, remember, once I press my bump switch, it's going to do whatever else follows. So I want you to watch this. I'm going to make my number of presses equal my number of presses plus 1. So every time I hit this bump switch, the variable number of presses, if you just want to make it X, you can make it X, is going to go up by 1 immediately. And then it's going to follow the rest of the program. Give me a sec. The next thing I'm going to do is I'm not going to actually have an infinite loop here anymore. I just want my program to run 5 times. So what I'm going to do is I'm going to do while the number of presses is less than or equal to 5. So whatever I have inside of this loop is only going to happen as I press the bump switch 5 times, because it's going to go to the top of this while loop after it does whatever I want it to do. In fact, I'm just going to delete this because who cares? I don't know how many braces I need, but I'm just going to get rid of everything. Okay. So right now I'm going to push the bump switch 5 times and something's going to happen. So let's see what happens. We can do something as simple as start the motor. Let's start the right motor at 60. Let's count for maybe 5 seconds. Let's do a wait on here. 5. So it's going to run it for 5 seconds. Let's stop. Let's stop the motor, right motor. And and then it's just going to wait. It's going to wait for me to put the bump switch on again. Let's change this because it's going to take forever if I have it at 5 seconds. So this goal is for me to show you the number of presses, how you can set an integer. So we're going to run this for 5 times. And you can add, obviously, anything you want inside of here. You could add, let's see here. You could have all that stuff happen, but like wow, you could have something like a while loop and have like a flashlight on for something else. It's just kind of, you can do whatever you want. Some programs like I've written are hundreds of lines long. So you just have to make sure that you put everything where you want it to put. So let's do this real fast so you can see how an integer works. Hopefully I have all my semicolons where they need to go. Okay. All right, I was upset I didn't have a semicolon up here. It's still going to run. However, I should have had a semicolon there. So let's see. Let's check all my, it looks like my parentheses were good. So it is just waiting for me to hit the bump switch. So ready? Wait. What's going on? What is going on? Hold on. Let's pause the video, see what's wrong. All right, guys, I think I got it figured out. It was something dumb here. When you do the bump switch, it's not a button press, it's until bump. So let's fix that up. Okay, so it's until bump switch. So that's why I kept holding, because I didn't have this until right. I had to go back to find some of my old code to figure out what I was doing dumb. Oh, I should have put that semicolon in up there. That's all right. All right, by the way, this is not making it run forever. This is only making it run hopefully 5 times. So hopefully I've got everything all fixed here except for that silly semicolon. Something important to remember the integer, the number of presses set to 0. I set that at the very beginning. Okay, now let's do it. So it's waiting for me to hit the bump switch. Run for twice. Now the bump switch, I'm not sure if you can do that. Maybe it's under local variables. No, global variables. There it is. Look, you can see the number of presses went up by 1. So if I type this again, it's going to run again. And now it's up to 2. And then 3, 4, and 5. I really want you guys to look right here because this is kind of neat. It shows you what it is. 5. And then I'm going to hit it again because I said as long as it's going to go stop, and then it's going to check. It's going to say, hey, is it still less than or equal to 5? No, it's not. It's 6 now. So it's going to end the task. Now, if you are thinking, which maybe you do, or you are thinking like, hey, Miss Langeli, that ran 6 times. That's because your algebra teacher can't count. And I forgot I didn't set it at 1 at the beginning. I set it at 0. So it's going to do it for 0, 1, 2, 3, 4, 5. It's going to do it for 0, 1, 2, 3, 4, 5. It's going to do it 6 times. So if I only wanted to run 5 times, so this actually makes it run, I'll say 6 times the way I set it up because I started at 0. All right. Now what I'm going to do is I'm going to pause the video and I'm going to think about how to get you guys involved with this a little more. Okay, last one. I promise I never taught you guys about the encoder or something you could do with it. So I did something with the encoder and I took my integer off. Let's see. So I made an infinite loop and I wrote the encoder. Now what I want you to see is encoders. You might want to start the encoder by setting equal to 0. Maybe you could even do something like right here, like set encoder to 0. But right now my encoder is reading at 667. There is a way, and you can always research it, to set the encoder to start at 0. And that would actually probably be a good thing to look up. Hold on. Okay, I found this like really cool website where somebody has like designated like they want you to do something. You type it in here, and then you can compile it and see if it works. If any of you want to, this website, if you want to copy that, that looks amazing. So I just stole this right here and how to set the encoder equal to 0. I pasted it in here. Ours is just called encoder. So there. So at the beginning of my task before my while loop, I set my encoder to 0. Let's download and compile that. And this is just a very basic, pretty simple step, but I wanted to show you how the encoder works in a program. Come on, little buddy. All right, everybody. So what I want you to see is my encoder should, as long as I do everything right, when I hit start, my encoder should go to 0. All right, right now you can see my encoder is at 667 down here. I'm going to hit start, and we're going to hope and cross our fingers that it starts to 0. It does. And that is because I set my encoder equal to 0. Now, I wrote here, if the sensor value is greater than, in other words, if I turn it more than twice, I should turn my flashlight on. So here's the encoder. I'm going to turn it twice. Oh, I'm turning it the wrong way. I have to turn it this way. I'm looking at my encoder value, 430, 500, 600, 720. Flashlight, whoops, oh, I didn't realize flashlight has turned off. Now what's interesting, if you go back down, flashlight turns off. Now if you wanted that to stay on all the time, you would get rid of my else statement. So if you no matter how if once it turns on, you want to stay on, you would have to get rid of the else statement. Otherwise, it's going to turn itself off when you go back to 720. Something you can do, and maybe I'm going to put this challenge out there, is you can run a motor according to the value even of like your potentiometer. That would be amazing. But that's for another day. Like you could, I wonder if maybe it's not for another day. Maybe we can super do this fast. Start motor, right motor. There's got to be a way. Maybe it'll be fun. So there's somewhere you can do like a sensor value here. Let's see. And let's see, what if you took the sensor value of the potentiometer and you divided it by 100? Because, you know, they go to like 4,000. I just want to see what this does. I think this could be fun. Let's see if I did this right. If I didn't do this right, I promise I'm going to stop and I'll make this one another day. But I wanted to show you can do the speed of your motor based on your potentiometer. Is it going to work? I'd be really impressed because I've never done this before. It says you have too many. Okay. I took out a couple of things. This would be awesome if this worked. I've never seen this work before. I've never actually done this, but this can control the speed of your motor if you do it right. I think this is the right motor. We're going to figure it out real quick, aren't we? I'm going to be excited if this works, guys. Ready? Uncharted territory. All right, let's see if it works. Potentiometer right now is 2,000. Oh, bummer. It's not working. You know, it'd be fun though. Is if I have to start. Oh, guys, look, it's working. I'm so stoked. Look. I'm so excited. Let's look at the values of our motors. So you can see your right motor is at 40. Watch, I'm going to like turn the potentiometer down. Oh, it's so cool. So you can, as long as you remember potentiometers go up to 4,095, you don't want to divide it by like 10 because that will burn out. You can't go to 400 on this. Okay, there you go. I've never been able to do that before. And I bet I can stop it. Ready? Okay, that was exciting for me. I promise I'm done.